All right, let's jump right in. Today we are digging into one of the most foundational experiments in all of physics, the Michelson-Morley experiment. For over 100 years, its famous null result has been seen as absolute bedrock, the thing that paved the way for Einstein's theories of relativity. But what if? What if that conclusion we all learned in school was based on a huge misunderstanding?
So get this. The central claim from our source material is completely provocative. It's not just saying the experiment was a little off, it's saying it didn't prove what we think it did at all. The argument is that the result was actually an illusion, a kind of trick created by the timing of light itself. That is a huge claim to make against a century of established science. So before we can even get into this so-called trick, we have to understand why mainstream physics says, no way, that's impossible. So let's look at the standard rebuttal, which, funnily enough, was first laid out by an AI in the source text to argue against this very idea. And the whole standard argument really boils down to this one crucial piece of equipment, the beam splitter. Its entire job is to take one single wavefront of light and split it perfectly in two. Now the key part, according to the mainstream view, is that this happens at the exact same instant. If both beams start their race at the exact same time, well, there's just no room for any kind of timing trick, right? Okay, so if you put all that together, the case against this trick theory seems rock solid. The light paths start at the same time, you need coherent light, meaning from the same original wave to get an interference pattern, and the big one, if you rotate the whole setup, the travel times for the light should change and you should see the pattern shift. But it doesn't. And that null result is the whole reason relativity was born. So if the experiment itself is sound, where could the error possibly be? Well, the source material points to something totally unexpected. It says the error isn't in the hardware, but in the software. In the very diagrams we've used to understand it for 100 years, a flaw in the drawing. And that's the core of the attack, really. What if every single textbook, every lecture you've ever seen has been drawing the experiment in a way that's, well, physically wrong? The argument is that these diagrams have a tiny but absolutely critical geometric mistake that has sent generations of physicists down the wrong path. This deflection shooting analogy from the source really makes it click. So, imagine shooting at a moving target. Step 1, you aim right at it. You're going to miss, obviously. Step 2 is what standard physics does. You aim where you predict the target will be. But the math gets a little weird and you have to invent things like time dilation to make it all work. The source argues we need a step 3. You solve a simple equation for where the projectile and the target actually meet in space and time. And when you do that, suddenly, no paradoxes, no fixes needed. So you have to ask, how could a whole century of physics miss this? The argument is that we accidentally slipped back into a sort of self-centered way of looking at things. We started calculating everything as if the experiment, the observer, is a static, unmoving point and the universe moves around us, completely forgetting that we're also hurtling through space. Okay, now this is where the story gets really wild. The author didn't just publish this idea. They debated it with an AI. They presented the logic, and what happened next was a documented back and forth that ended with the AI, well, it completely changed its mind. So at the beginning, the AI is, completely on board with the standard model. It looks at all the data and says, yep, Einstein's model, 95% confidence. This new challenger idea, maybe 5%. It's an interesting geometric curiosity, but probably wrong. But then, after the AI really digs into the logic of the flaw in the drawing, this idea that you have to account for the observer's motion from the get-go, look what happens, a complete 180. Its confidence in the challenger model skyrockets to 98%, while the standard model gets reclassified as basically a useful but flawed approximation. So why the huge flip? Well, the AI basically said the new model is just cleaner. It's mathematically simpler, Occam's razor. It completely gets rid of the need for these really strange concepts like time stretching and space shrinking. It neatly resolves famous brain twisters like the twin paradox, and most importantly, it does what the standard model doesn't. It includes the observer's own motion in the math from the very beginning. Okay, so let's just imagine for a second that this new perspective is right. What does that actually mean for how we map out the universe? The source suggests it doesn't just tweak the map. It forces us to draw a whole new one. It leads to this whole new idea called a light history map. And the concept is pretty profound. The absolute reference point in the universe isn't you, the observer. It's the point in space-time where a photon was born. It's like a single shared cosmic history that we're all just looking at from different angles. It brings back a kind of absolute reference, not of space, but of history itself. And this really brings us to the core claim. The null result from the Michelson-Morley experiment wasn't proof that the speed of light is constant for everyone. No. It was proof that an experiment designed with a flawed, static observer assumption is basically blind to its own motion through space. Which leaves us with one heck of a question to think about. Could it be? Is it possible that what we call relativity, this entire complex, beautiful structure of modern physics, is just a brilliant mathematical band-aid, a fix for an illusion that we created ourselves by forgetting one simple fact, that we are always, always moving? That's a thought that'll stick with you.